join करो. रेडी पड़ेगा शर्मा सर हो गए. So just it's good morning to all of you. Just within fraction of time we will start the inaugural function. Have a questions.
Good morning.
Good morning, sir.
Yeah. Good morning, all of you.
Dr. Brajo, am I audible? Dr. Brajo, am I audible?
Yes, sir. You're audible, sir. You're audible, sir.
Sir, namaste, sir.
Dr. Brajo, am I audible?
Yes, sir. Yes, sir.
Audible,
Good morning.
Audible.
Namaste, sir. Namaste. Sir,
Am I audible?
Yes, sir. You're properly audible and no problem. Sir.
Okay, yes, sir. I think this is.
Sir, good morning, sir. Vice Chancellor, sir, good morning.
Sir, meanwhile, already our chief guest joined with us.
Dr. Brajo, your speaker is off, perhaps.
No, sir. Sir, am I audible,
I cannot hear you.
You're audible, sir. You're audible.
Dean's audible, sir.
Yeah, good morning.
I cannot hear you.
But he is not able to listen as our VC sir. Dean, academic sir.
Yeah, we can hear you.
Brajo, sir, am I audible?
We can hear you.
Yes, sir. Yes, sir. Both of you are audible to me, but as VC sir is saying that I am not audible to him.
Yeah, VC, sir. I think. Sir, VC, sir, good morning. Am I audible to you?
Yes, sir. You are audible.
Yeah.
Perhaps there is a problem with VC sir's system. Perhaps. Sir.
Hello?
Sir, it was VC sir's system phone
Hello?
problems. What is the sir mobile join करेंगे no.
Hello? Am I audible?
Yes, sir, you are audible.
Problem might be on your system, sir. I'm just sending the link to your WhatsApp mobile. You will join from the mobile, no problem.
No, I am saying am I audible?
Sir, you are audible, sir.
Yes,
But
sir.
are
Yes,
we,
sir.
are we audible to you?
Okay, okay.
Sir, I'm sending you.
You are sending
No,
you are sending a different link.
same link to the mobile WhatsApp I'm sending to you, sir.
No, but I am connected already. Do you think I need it?
Okay.
Okay.
Very good morning to one and all present over here. As a coordinator, let I will introduce myself are Dr. Kanchan, Associate Professor, Department of Mechanical Engineering, JIT University, Gurukul. Welcome to all of you in this online FDP program which is sponsored by AICTE. It is my pleasure to welcome our chief guest, Professor Suresh Kumar Garg, Pro Vice Chancellor, Delhi Technological University, for this AICTE sponsored FDP program. Sir, namaste sir, you are most welcome for this FDP program.
Thank you very much. Thank you so much.
Thank you, sir. I take the privilege to welcome our Honorable Vice Chancellor, sir, Dr. Gautam Bose, JIT University, to this program. Welcome, sir. Welcome for this online FDP program. I welcome the Dean Academic, Dr. Abhinal Sharma, sir, JIT University, to this FDP program. Welcome, sir, for this program. I welcome Dean R&D, Dr. JBV Subramaniam, sir, JIT University, Gurukul, to this FDP program.
Thank you.
You are most welcome, sir. I welcome Head of the Department Mechanical to this FDP program. Welcome, sir, for this FDP online program. I welcome all the faculty members, Head of the Departments of JIT University, press and media peoples, and I welcome all the participants who enrolled for this FDP program. Along with, I specially invited the speakers of the program. All of you are welcome for this online FDP program, sir. JIT University Gurukul, Odisha, was established by Vidya Bharati Educational Trust Gurukul in the year 1997. The Department of Mechanical Engineering is an oldest department of this university and provides BTech program, MTech programs, and PhD programs in various disciplines. In the near future, most human-intensive tasks will be accomplished by machine. Therefore, it becomes essential for mechanical engineers to upskill themselves and get acquainted with the advanced technology. This is an AICTE-sponsored 2 weeks online faculty development program on application of artificial intelligence and machine learning in digital manufacturing. Experts of this program from reputed organizations throughout India have given their concern and they are interested, and also they will share their experience in various advanced topics during these sessions in this online FDP program from 2nd November to 14th November 2020. Now, with a warm, heartfelt welcome to all of the participants, chief guest, vice chancellor, deans, registrar, head of the departments, and faculty members. Now, I request HOD Mechanical to tell few words in this program.
Good morning, one and all. Respected dignitaries, respected chief guests, all head of the department of JIT University. First, I have to thankful to the management for their support to organizing this sort of events. So not wasting much more time, Mechanical Engineering Department, which was established in 1997, has emerged as a powerhouse of the academic, scientific research and cutting-edge technology. So we are the one of the oldest branch of the GIT University, followed by we have various center of excellence with various organization, various industry. So our department organized this sort of event in its past. So I welcome all the dignitaries, all the participants. I think so coming days will helpful for you to have a glance on application of artificial intelligence and machine learning in digital manufacturing. I hope you will enjoy the session in the coming days. Thank you.
The department. Thank you. Now I request Dean R&D, Dr. J.B. Subramanian sir, GIT University, to tell few words in this program.
Yeah, a very good morning to one and all to all the dignitaries present over here. Can you hear me, Braja sir? Hello?
Yes, sir. Yes, sir.
Yes,
yeah.
please. Yes, please proceed.
A very warm welcome to all the dignitaries present over here and all the participants. A great appreciation to our Mechanical Engineering Department, especially Dr. Kalicharan Rath, for obtaining the sponsorship from AICTE in conducting a 2 weeks online FDP on application of artificial intelligence and machine learning concepts in digital manufacturing from 2nd to 14th November. We wish a grand success for this program. I request all the participants to concentrate, interact with all the experts, and then learn the important concepts and to apply them in your life. Thank you so much. Thank you.
Thank you for your valuable words. Now I request Dean Academic, Dr. L. Sharma sir, GIT University, Guntur, to present his valuable words in this activity program.
Yeah. Good morning to one and all. So, on behalf of my management, President Sir Dr. S.P. Panda, Vice President Sir Dr. Chandradhwaj Panda, Director General Jagadish Panda Sir, Vice Chancellor Dr. Gautam Ghosh Sir, Registrar Dr. N.V. J. Rao Sir, all deans, heads of departments, faculty, students, research scholars, I extend a warm welcome to this AICTE sponsored 2 weeks online FDP on applications of artificial intelligence and machine learning in digital manufacturing. To our Honorable Chief Guest, Professor S.K. Garg Sir, Pro Vice Chancellor, Delhi Technological University, and other experts who are delivering their talk on this particular topic. So, in short, I would like to say that this is an intelligent manufacturing. So, changing manufacturing, in other words, it is also called as changing manufacturing practices since post-COVID-19. So, new technologies will increase the scope and the quality of work, turn the manufacturing practices more sustainable, flexible and cost efficient, and will require smart leaders to manage them. It will change the industry overall in terms of better customer satisfaction, enhanced economic ecosystem as per our guidelines of Atmanirbhar Bharat. So, in short, I would like to tell the scope of this application of smart manufacturing. We have artificial intelligence in product development and process automation. So, that is where we require. Similarly, implementation of Industry 4.0 processes, and also to develop simulations and test cases for safety and automated driving functions. For example, to analyze post-crash behavior, where we need hundreds and thousands of test runs of the system to ensure 100% accuracy, I strongly believe AI and ML is going to give a large virtual reality in creating such simulations. So AI for better optimization of process and productivity, And in near future, we might also see the implementation of virtual reality and the connected technologies in product planning and quality designing, solve frequent shop floor problems, and much more. The possibilities are infinite. So therefore, the newer technologies are also addressing the inhibitions raised due to COVID-19 through less human-to-human contact and need to travel, etc. So this in turn will lead to a higher accepted rate of such technologies. For example, before COVID, there was a large possibility for Ola and Uber. And now in the present scenario, the need for individual transport, the individual cars hiring has been rapidly increasing, and there is less importance for public transport. Similarly, with new regulations coming in these technologies, we also find more and more relevance in manufacturing plants. Automated guided vehicles being used within the plant for material movement on shop floors. This also reduces the unnecessary movement of the human beings and thus reduces the risk of physical contact. These regulations have created an opportunity for developing and deploying new age technologies to create a safer and advanced shop floor ecosystem. And also the use of data analytics, the artificial intelligence, the machine learning, it is certainly going to give a path for uncertain predictions into certain predictions. So with these few remarks, I invite our Vice Chancellor, sir, to proceed with the next one. Thank you, sir.
Thank you, sir. To request Vice Chancellor, GIT University, Dr. Gautam Ghosh, sir, to speak a few words.
Very good morning to you all. Honorable President and Vice President of this university. Unfortunately, due to preoccupations, both of them are not in town. Honorable Chief Guest, Professor S.K. Garg, Pro Vice Chancellor of Delhi Technological University. All the faculties, members of the Department of Mechanical Engineering, head of the department, deans of the schools, and last but not the least, the person who made the last moment follow up with me everything is Dr. Kalicharan Rath, coordinator for this 2-week FDP program. The topic of this program is very pertinent on today's context. As you know, there are so many amazing ways that artificial intelligence and the machine learning are used behind the scenes, which are impacting our everyday life, including the information business decisions. The mechanical engineering in AI is above all an opportunity to maintain a worldwide leadership. Production processes, as mentioned already, can be optimized. The machine and services are extended by intelligent functions through an embedded AI system or AI solution. Manufacturers are always keen to adopt technologies that improve the product qualities, reduces time to market, and scalable across their units. Therefore, AI, machine learning, robotics, automations are helping manufacturers fine-tuning their product quality and optimize the operation process. Students who are actually trained in mechanical engineering and have a good understanding on the AI and ML are actually valued in the companies across the world. Therefore, upskilling with AI and ML can always help engineers to gain a competitive advantage in this fast-changing digital world. With these few words, I again wish the Department of Mechanical Engineering for holding this 2-week important faculty development program, which is being participated very distinguished members and participants across the country from leading institutions. We are all thankful for you for doing this very good program this particular time when everything looks so difficult. Thank you very much. Thank you again to you all and also present for your participation. Thank you.
Thank you, sir. Thank you so much for your valuable importance. You can say that words towards the importance of the topic in the recent arena. What is the required by the market? What is the required by the engineers and the students community? Now, a humble request to our chief guest, Dr. S.K. Garza, to address the gathering. So I can able to say that only his dedication each to the society is his message. So he's such a nice person and such an you can say that very vast research field in the advanced technology. Welcome, sir. Welcome. Now I request Dr. S.K. Garza to address the gathering.
Good morning, everyone. It is my profound privilege to be here with you at the inauguration of 2 weeks faculty development program, AICTE sponsored faculty development program on applications of artificial intelligence and machine learning in digital manufacturing. At the outset, I am thankful to the Vice Chancellor, Professor Gautam Ghosh, Registrar, Dr. N.B.J. Rao, Deans, Professor Dr. V.K. Mishra, I met him last year, other deans, Dean Academic, Dean IRD, HOD Mechanical Department, Professor Mohanty, and most important person, as Vice Chancellor has said, Dr. Kalicharan Rath, for taking all the pain and doing all the efforts, following up with the speakers and other persons, secretaries, Dr. S.K. Mishra and M.R. Panda of the program. And I'm also thankful to the President, Professor S.P. Pandaji, and Professor Chandradhwaj Pandaji and Professor Jagdish Pandaji for creating this opportunity for all of us to discuss, to get more knowledge on a very important topic for today's environment, where everything we are talking about machine learning, artificial intelligence, and manufacturing. If you look at that, manufacturing plays a very important role in the economy of any country. Today, at present, manufacturing has around 18% contribution in the GDP of India, and the target of the government is to raise it to 25%. And second important dimension, along with raising the manufacturing component, important thing is we should be able to export these items, export our manufacturing, which at present is not happening. That's why Government of India is thinking on Make in India and Develop in India, R&D in India, so those kind of missions, projects. So in that context, the role of engineer, especially mechanical engineer, is very important in producing and manufacturing products which meets global standard in the form of good quality, in the form of competitive price, and in the form of deliverable, timely delivery of the thing. And this is where somewhere India, in many sectors, we are good, but in most of the sectors, Indian manufacturing is lacking. Our products are not admired globally, and the cost of manufacturing is also high. The government is doing several policy interventions to reduce the cost, improve the quality. But I believe that the technology will play a major role in improving quality, reducing cost. And this is where I see the role of machine learning, artificial intelligence, etc., etc. Friends, the role of computers came somewhere around 4 decades back. At that time, we were saying automated manufacturing. But now, in the last 1 decade, thanks to the other meta technologies like cloud computing, like big data, the artificial intelligence and machine learning is founding applications in the manufacturing. This is all because of Internet of Things. So many terms are said in isolation, where they all convey one or convey the same meaning. And we are talking about Industry 4.0 also. So these technology, these terms, where we are converting our physical manufacturing system into cyber physical system, that means each of our physical assets is having some kind of a digital chip placed on that, which collects the data about that manufacturing process. And this data is sent back to the cloud, and where machine learning, artificial intelligence is doing the analysis and giving back to the feedback to the processes for the purpose of control. You will remember that in 90s, sensors and actuator technology was getting into manufacturing, into our products, etc. And we are, many institutions started mechatronics also, combination of mechanical and electronic. But now we are, in the last 3 days, we are much ahead of that particular time. Now we are more talking about smart manufacturing. In smart manufacturing, the processes are maintained with the help of artificial intelligence, with the help of machine learning algorithms. So in that context, I'm very happy that you are organizing this 2 weeks faculty development program. And I saw your timetable also, where you have covered almost each and every aspect of machine learning and artificial intelligence and along with lean manufacturing. I'm also very happy that very senior resource person you are able to rope in for this particular workshop. So my humble request to all the participants is to take full advantage of this opportunity by giving your 100%, not only in the class, even after the class also, understanding those concepts, reading more on the electronic media, Google or other resources, finding out research papers on those topics, and developing your own pedagogy for this particular theme. Another important aspect, you will find that with the help of these technologies, we will be able to make precision manufacturing a reality in India also, because these sensors and actuators will help in getting the real-time data from the manufacturing processes, and then feedback with the help through this artificial intelligence analysis. Feedback is given to the actuators to set the system at the desired level of process parameter. And these digital twins are also helping, are going to play an important role in our energy sector also, health sector also, environment, and you name it. And every sector of the society is going to be influenced in coming years with this, these technologies, with the application and interventions of these technologies. These days, one of the thought which comes to my mind, how to properly implement this in our academic curriculum. This is my personal thought, that now a time has come where in the mechanical engineering department, we should have 1 or 2 professors of electronics and 1 or 2 professors of computer science. And simultaneously, in the computer science and IT and such department, we should have at least 1 faculty of mechanical engineering, 1 faculty of civil engineering, 1 faculty of other area. Maybe if you are having polymer or chemical engineering, whatever branch you are having, 1 person should be there. So that when we are in mechanical department, whenever we are developing the projects, etc., we should have a collaboration with the electronics, with the help of computer science. And these faculty members of computer science and electronics will also understand the applications of their work, applications of their algorithm or whatsoever they are developing. They should be able to connect that with the application. They should have a knowledge of power plant. They should have a knowledge of how the automobile vehicle is working, and so on. If you see the present day automobile, if the cost of the vehicle is 10 lakh, the mechanical components cost is only 1.5 to 2 lakh. Remaining 7-8 lakhs is coming through electronics, computer science, and other things. So it's very important that mechanical engineers must understand the electronics aspects, must understand the various microprocessor controllers which has been working in the mechanical system. Around 4 years back, I visited US and found that one research scholar was working there in removing the steering stem from the car. He said that the role of the steering stem is only to send the signal from the steering wheel to the wheels of the car. So why not, why this such a big 15-20 kg metal is required to perform that task? If this whole steering system can be eliminated and converted with some electronic components, so signal is created at the wheel just like in our video games, etc., and it is given to the actuators or motors close to the wheels. So those kind of things are being worked out in our lifetime. In next 5 or 10 years, we will find on one direction we are talking about electronic vehicles. In the our conventional vehicles also, you will find more electronics will come, and the role of materials, metals will keep on declining. So in that context, we have to look at this subject of artificial intelligence and machine learning. It is very, very important for core branches, because all core branches are, their role is only 15-20%, and other layers of electronics, machine learning, and they are going to play a major role in the efficient operations of these manufacturing systems or products. And that's why you see General Electrics and all such big companies, which used to be turbine companies or mechanical engineering related companies, now, or electrical companies, core companies, now they are having around 60 to 70% of their revenue is coming through electronics and computer or such kind of services which they provide, or in the form of data analytics or this thing. This also plays a very important role in predictive maintenance, predicting the health of the equipment, so that timely action can be taken and the downtime of the equipment can be reduced. So in my opinion, it is going to play many applications, many interventions in coming years in our mechanical system, civil engineering system, all our bridges, buildings, etc. are going to have digital twin attached to that, and from where the data, minute to minute, second to second data is going to be collected, and with the help of these algorithms going to be analyzed and giving you beforehand warnings, predictions, etc. Just like we are getting all cyclone related information at least 24 hours in advance to a very high degree of accuracy. So these are the things which are happening, and we should be part and parcel of this, both as members of the society as well as an engineering community. We should contribute to this technologies, and we should try to incorporate this in our research, in our product development, and like that. One topic you have listed, last point from my side, Industry 4.0 and Society 5.0. I don't know how the Society 5.0 is going to be unfolded. What are going to be the traits of that? What are going to be the ingredients of that Society 5.0 when we are having such technologies, driverless car and driverless, personless, humanless, most of the things are going to be. One small story I would like to share, where we have to be cautious, a little bit cautious also about these technologies. The story is of a small boy, 7-8 years old, just like we are with respect to this technology. Our age with respect to this technology is also 7-8 years old. So that kind of innocence we are also having. He saw one thief surrounded by the policemen. Policemen are taking one thief to the police station. The boy asked his father, who is he? And who are the person who was surrounding him? He was innocent, first time came to the city, and he saw that scenario, villager. His father explained that the person inside is the thief, and he is being surrounded by the policeman at that later. Boy agreed to that. Few days from this incident, he found that king is surrounded by the policeman. A king is moving on the road and surrounded by the policeman. The boy shouted, Papa, another thief. Now father explained that, Beta, this is not a thief. He is king of this place. Then he said that, what is the difference? The other day also person was surrounded by the policeman, you called him thief. Today again a person is surrounded by the policeman and you are calling him a king. What is the difference? He said in the first scenario, thief was surrounded by the king. So by the policeman. Their policemen were controlling the thief, and that's why he was a thief. And now in this case, king is controlling the policeman, so that's why he's a king. So we have to see with respect to these technologies of artificial intelligence and machine learning and other such things, whether these technologies are controlling us or we are controlling these technologies. If these technologies started controlling us, our life is going to be a hell, just like a thief. On the other hand, if we are the king, we start controlling these technologies, we do not allow this to overpower us, then we will use these technologies as a king. So this is a small message for all of us. Now we are so addicted to WhatsApp and other social media. So we are becoming slave of these technology. So rather than becoming slaves of this technology, we should change our attitude, we should change our mindset and work as a king of these technologies. And these few words, once again, I am thankful to the organizers, Dr. Rath, management of the institution, Vice Chancellor Sir, and other dignitaries, other persons, the team of Professor Rath, who has put all their efforts in making such a beautiful bouquet of timetable for this, for the benefit of this audience. And last but not the least, I'm thankful to each and every participant of this conference, this 2 weeks faculty development program. And I wish you all a happy time, a good learning, and wish you all good luck. Thank you very much. Thank you. This is from my side.
Thank you, Professor Garg. Thank you, Professor Garg. Thank you. Hello? Is it a technical glitch?
No, I am over. I am completely.
I'm saying the other.
Each and every one of you for this opportunity to meet, for giving me opportunity to share my points and be with you. And I also I have requested myself. I would also attend few of the sessions depending on my time schedule.
It was, yeah,
it
was indeed an excellent talk, and everybody really learned and enjoyed. Thank you.
Thank you, sir. Thank you. Thanks to the AICTE to provide sponsorship to conduct such a nice FDP program. And especially thanks to the chief guest, Dr. Garg sir, who has given time from his busy schedule to be with us for today's inaugural function. And sir will also, sometimes he will visit in any program in between these sessions. Thanks to the management, President sir, Vice President sir, Director General, and Vice Chancellor sir, Registrar sir, Dean Academic sir, Dean R&D, and actually Mechanical, along with the head of the departments from other disciplines. I guess special thanks to the press and media to be present here. And thanks to the technical person who will help me for this program to conduct such an FDP online program. And thanks to Dr. Garg sir and Dr. Raghavendra Kumar of the CSE department for giving a guideline to proceed how to conduct this FDP smoothly. And give the special thanks to all of them. And I thanks to all the participants who enrolled for this program. Till now we are receiving phones for request to enroll. But here I am telling you that near about 200 participants already enrolled for this FDP program. So round to stop for the response. And after a few days, 15 to 20 days, we are going to conduct the second FDP with the same title for the different speakers. So thank you to all to be present here, to be speak something on the, or to know or to say about this advanced technology in this FDP 2 weeks FDP program sponsored by the AICTE. Thank you to all. Dear participants, we share the Google meeting link as well as the YouTube link to every participant, and we will share the feedback. We were planning that either through the mail or in the sessions. Right, the feedback link will be open for 10 to 15 minutes only. And as per the rule, we have given that all attendance, our participants are bound to attend all the sessions, including giving the feedback at the end. Number one. Number two, after completion of the program, we will conduct a test. We will qualify as per that rule. They will get the certificates. Now, we will start with the sessions. Just a moment. Kaushik sir. Kaushik sir. Kaushik sir, are you hearing me?
Hello, Brojo. Yes, I am here. Very good morning.
Dr. Kalicharan.
Okay.
Kaushik sir, namaste.
Namaskar.
So let's we invite our first speaker of the session 1, Dr. Kaushik Pal, who is currently working as a professor in the Department of Mechanical and Industrial Engineering at IIT Roorkee. So he has a vast experience in the research area. So he will tell today he will take over this today's session. He is a synthesis. His interest area, working area is the synthesis and modification of advanced nanomaterials, high performance humidity and toxic gas sensors applications, energy harvesting and storage applications, biomaterials for targeted drugs delivered towards cancer cell, etc. So he is associated with so many professional society also. Sir, I can able to, if I will tell that it will take more time because he has such a nice and excellent biodata, and we are just only a sign of a C. So before going to start the session, I heartily welcome Dr. Kaushik Pal sir, Professor IIT Roorkee, for this session to take over the session and tell about and something on this particular FDP programs. Welcome, sir.
Yeah. So just give me some time. Just let me share my presentation first. Can you see my presentation?
Yes, sir.
Okay, fine. So a very good morning to all of you. As Dr. Brojo and Rath has already explained about me, so I am not going into the details. So my name is Kaushik Pal. I am the professor in Department of Mechanical and Industrial Engineering at IIT Roorkee. So basically today, first of all, I am very much overwhelmed that the GIT University has recognized me as the opening speaker for this very interactive and very newly advanced topic, that is the artificial intelligence and machine learning with digital manufacturing. So I am really thankful to all the administrations, and of course it is my pleasure because after a long time, because when I am coming back to my institute, because I am the BTech of this particular institute and I was the student of second year basically. So I completed my degree from here from 2002. So of course it is my pleasure because when I am coming to my alma maters, and of course I am sharing my knowledge with all my juniors and all my teachers, and of course the administration point of view. So just today my lecture is basically that how we can integrate the artificial intelligence and the machine learning with digital manufacturing. So nowadays, everybody is talking about the artificial intelligence and machine learning with digital manufacturing. Everywhere, basically, this is coming. So because nowadays we are going to the modern era, we are trying to decrease the, of course, the manufacturing cost, or maybe the human error, or maybe the saving the time. And of course, the main motto of any industry or maybe anything is that just to increase the productivity. So these two things, that the artificial intelligence and the machine learning is the main topic, or maybe rather I can say the hot topic, which is going to rule the whole industry or maybe the whole manufacturing side for the near future. So first let us know that what is basically the digital manufacturing. So every time we are talking about the digital manufacturing, so what is the difference between the digital manufacturing or maybe the normal manufacturing or process? So as I know, the manufacturing means the term is manufacture. That means you are assembling or maybe you are preparing something. So you are having one shape of the materials or maybe one shape of the products, and you are going to give the final shapes or maybe the final any kind of designs or maybe final any kind of things to a particular material so that it can be useful for the human or maybe for the mankind, rather I can say. So basically, if you take the examples, so I can give you, suppose any kind of metals or maybe any kind of wood or maybe any kind of raw materials. Still it is into the raw materials or maybe it is into the ore or maybe the lump or like a wood that we are directly getting it from the tree. But that time when we are getting all these things directly from the source, it is not at all unusable. So what we are doing, we are processing those things, and we are processing, suppose some impurities are there, we are removing all those, we are giving a particular shapes. For wood, we are doing the seasoning kind of things so that it can sustain for a longer time, and then after that we are giving a particular shape and size, or maybe as per our requirement we are preparing the any kind of products. So basically the making of parts or products as per the customer's expectations, that which I was talking about basically. So depending upon that, what type of shape and size basically we need, what type of applications it is, based on that we are choosing the materials, as well as we are choosing that how to prepare those materials. We are doing all the finishing kind of things, and then we are using it. So it's everywhere. Now it is manufacturing is everywhere, because no product or maybe no material till now, whatever we are directly getting, just we are taking, except some food materials, of course, because there are lots of food materials which don't need any kind of preparations kind of things, but except any other type of any kind of utility goods or maybe any kind of things that we can directly get it from the environment, rather I can say the environment, or maybe from the earth itself, and then we are processing all those and we are making it useful one. So manufacturing is nothing but it is a process of converting the raw materials into the finished products. Of course, it's true. So basically what in that case, what we are doing, we are having any kind of materials, we are giving a particular shapes, and then we are using it for the finished products. Now come to the digital manufacturing. So till now, whatever we are talking about, that is the simple conventional manufacturing process, or maybe rather the maybe I can say the simple manufacturing process. But when I am talking about the digital manufacturing, so basically what is digital? Digital means it is something based on the programs, or maybe it is done by the computers, or maybe some other brains rather than the human brains basically. So it is a use of computer-based system to create a product via manufacturing. So earlier days we were doing simple kind of welding, or maybe simple kind of castings, or maybe simple kind of any kind of assembling. Now if you go to any industry, say suppose I can give you an examples of some automotive industry. So if you go to the automotive industry basically, so what they are doing, so basically they are making a car, and if you go any kind of automotive parts, so I can give you say simple examples of the Maruti. So depending upon the different models, so a car can make from a flat sheet to a full car is within 12 to 15 minutes. So now you can understand, from a flat sheet and you are getting the final car at your dispatch section, within a 12 to 15 minutes a car is totally preparing. So everything is now digitalized. Yes, of course there is certain kind of human interventions is present, but still everything we are making it digitally. A collaborative approach in product and the process design. Yes, of course, because nowadays the welding is doing by the CNC machines, any kind of machine forming kind of things is doing by the CNCs, or maybe any kind of suppose say engines, or maybe any kind of body parts, or everything is digitalized. So just you are doing, and you are bringing all those, and you are putting all those in a particular point, and you are assembling all those. It enables manufacturing engineers to provide immediate feedback to designers if there are constraints in the part manufacturability. Yes, of course, because there is always a feedback loop. is present in every step. So basically, if your machine thinks that no, this process is wrong or something going wrong, suppose it is doing the welding or maybe it is doing certain kind of machining kind of process. So in the CNC lathe, suppose your tool get damaged. So in that case, the machine will give the feedback to the operators. No, there is certain problems. So now you have to rectify all these things and then you can go for it. So it is a certain kind of things that whatever the manufacturing process, basically we are making it totally independent. Earlier days, it was totally dependent upon your workers or maybe those who are working or maybe the dealing with that particular machines. Now I am putting certain brains onto those particular machines or maybe some systems that they can think, they can observe, they can take the decisions, and of course they can perform it. So now basically that era basically we are moving to. So now what digital manufacturing allows for, say suppose first is that shortening of the development time and cost. Yes, of course, because when you are going for any human interventions over there, so of course the human, there is a chance of the error, of course, because in us industry generally, you know that after 8 hours or maybe the 10 hours that we are changing the operators, and all the operators doesn't have the same capability or maybe the same patience kind of things. So maybe after certain time they may exhausted and some error may occur, or maybe some processing, suppose you are measuring any things, suppose your length or height or width or something like that. So of course there is a chance of the error at every step, but when one machine is doing all these things, of course it is performing that duty very properly, and after certain time what will happen, it will never be exhausted. So what will happen if it is finding any kind of drawbacks over there? So simple, it will give the input to the operators that there is a certain problem, then the human intervention will come into the area, and then it will look, and then it will rectify, and then again the machine will perform the same thing. So automatically it is reducing the time, and of course it is reducing the cost too, because yes, of course, at the initial stage when you are installing these particular machines, of course it is very, very costly and expensive and all these things, but that machine can work for few years. So basically for 5 years and 10 years, and if you calculate the cost of your operator for 5 years and 10 years, of course end of the 5 years and 10 years you will see that the profit is there when you are using this kind of digital manufacturing rather than employing so many operators over there. Next, integration of knowledge coming from different manufacturing process and departments. Yes, of course, because when you are doing a process, suppose you are making a car, or maybe you are doing any welding or casting or a forming or machining kind of things, so you should have the proper knowledge, because you have to give the instructions to your particular machines one by one. So first you have to do this, you have to heat it, you have to keep your welding speed is this much, you have to hold your welding time for this much, and this will be your speed, and this will be your travel speed, and after certain time this you have to cool it down. So everything you should have the prior knowledge, unless and until if you put any kind of wrong input over there, so machine will also be like that. So that's why when you are going to do into the assembly sections, so you should have the proper knowledge with all your parts and all your manufacturing process and your fabrication process, so that you can be able to make it so smoothly. Decentralized manufacturing of the increasing variety of parts and products in numerous production sites. Yes, of course, that is also the another prime considerations, because earlier days when we are making any kind of I am giving the automotive car because it is having n number of different parts, and that n number of parts, some parts are made by the metal, some parts are made by the plastic, some parts are made by the ceramics, and there are n number of things. So it is a very good recipe of any kind of manufacturing process. Thus I am giving the examples of the automotive car. Say suppose any car company, They are making the car body, maybe they are making the engines, but there are some plastic parts, say suppose bumper, headlight, basically they are bringing it from some other companies. Car tire, so basically they are taking it from some tire company. So now after bringing all those things, they are doing the assembly. But when you are making the decentralized manufacturing and you are totally depending upon some machines and all these things, so slowly what will happen, these other products also, it can be made by you also, because in that particular case you need help of 1 or 2 experts, those basically who are working on the car tire or maybe the lights or something like that. And in your industry itself, so you can build or maybe you can set up that particular tire equipment over there. So the role of that expert will be that only it will give you the recipe or maybe the input parameters. So after maybe 5 years or 10 years, you will be able to make the tire in your own company too. So in that case, you don't have need to depend with some other company or maybe for some other industry. Focusing on manufacturing organizations on their core competence, working efficiently with other companies and suppliers on the basis of effective IT-based cooperative engineering. Yes, of course. Earlier days, I can give you a very good example. Earlier days, those who are having the old car and all these things, when the car get damaged or maybe get some accident over there, just you remember, suppose you are having any need any kind of denting and painting in your door or maybe the car bonnet, what you are going to do, either you are going to go for the car your manufacturer or maybe that car replacing unit or maybe the car where they are making the denting and painting of all these things, or maybe you can go to the local vendor also, some factory over there. So what they are doing, they are cutting it, they are putting extra metals, then they are doing so many things, polishing, welding, and after that again they are putting the painting and they are fixing it. It needs lots of time. But nowadays, if you see any kind of car body or car parts, so basically you can see that simple, you are having any problems in anywhere, simple they are taking it out and they are putting it newer one. So earlier days, maybe that part was made by the metals. So thus it is very easy to change it. Very easy. Is very difficult to change it or maybe replace it because it was requiring high cost over there. But nowadays, the maximum body parts is made by some kind of polymers or maybe the plastics, which is the recyclable one. So when you are taking it out, and then in future also you can recycle it and you can make it the newer parts too. So thus it requires the, of course, the cost, and automatically it is reducing the time. So simple, you open some screws over there and replace that parts, and your car getting new. So these all are the things that basically where the digital manufacturing is coming into the picture. Now, what is the basic components of digital manufacturing? So basically there are several components are available. So first is that CAD, that is the nothing but the computer aided design. So basically the computer, you are making any kind of designs through the software, AutoCAD, or there are n number of CATIA is there, AutoCAD is there. Nowadays MATLAB is booming over there. So many types of softwares are available into the market. So you are making whole the design. Nowadays, even if probably you have heard about that 3D printer also. So 3D printer has come into the market. Earlier days, it was only available for some particular polymers kind of things. But nowadays, these all is available for the metal kind of things also. So metal 3D printers has already come into the market. So that means now you can understand. Suppose you are making, or maybe you are doing any design, you are making it some kind of programming and all these things. So automatically that 3D printer will print that particular parts. Now simply you take it out and put it over there. So now you can understand that how automations or maybe this type of artificial intelligence and machine learning has come very closer to us, and it is how helpful to us. Next one is that CAM, that is the computer aided manufacturing. Then CAPP, that is computer aided process planning, that is generally we are using it for the industry. So industry, you can heard about industry 3.0, industry 4.0. There are so many things. So actually we are doing the modernization. Modernization means in terms of the digitizations, basically. Factory layout planning, ergonomics, MRP, manufacturing resource planning, ERP, entrepreneurs resource planning, computer simulation techniques, supply chain management, and e-commerce systems. So basically these all are the things. And also a few years back, maybe 1 year back, we have gone through all the things, all our monetary transactions into the digitizations. Now we are having so many softwares, and we can use it in our mobile, and we can pay it, we can purchase anything, we can send the money from one person to another person. So now you can understand that how basically we are depending onto the technology, how we are depending onto certain things. Next, first, let us discuss about the CAD. So everybody we know from a mechanical point of view, basically we know that what is the CAD, or maybe the computer-aided designs. But for your just remembrance, I am telling you one thing, that use of computers to aid in the creations, modifications, analysis, optimizations of a design. Not only that, the CAD is nothing that you are going to design anything new. Suppose you are having any existing products also, that also you can do the replicate in your particular software, and then after that you can analyze it, what is the life of that particular product, where the problem is that if some portions has been worn out or maybe the broken, so you can easily rectify all those problems. Then you can repair those problems and resolve those problems, and then you can use that particular parts for the future one also. No need to throw it out. So CAD software are used to increase the productivity of the designer, improve the quality of design, improve communications through documentation, and to create a database for the manufacturing. Yes, of course. Earlier days also we are facing certain problems. Nowadays also so many. Suppose if you are going to any shops, I can give you the examples. Suppose you are going to any shops or maybe any industry or something like that, or maybe some restaurant, suppose. So everybody has faced this problem. So when you went to that particular restaurant maybe 1 year back, so one food item you have taken, but that time the taste was very good. Now after 1 year you went to the same shop once again, and you have taken the same food, but you feel that the quality has been either good or maybe the bad. It is not the equal. So that then if you ask the restaurant owner, so maybe they can give the answer, sir, that time our chef was someone different, and now the chef is something different. So basically your cooking style has been changed. Now suppose you think that if you are having any machines which is producing that particular food for a longer time, so whether you go it for 1 year before or maybe after 1 year after also, doesn't matter, because you will feel the same quality and same taste over there. So that is the thing. That means when you are talking about any kind of CAD kind of things, so always you are keeping it into the database. So it doesn't depend upon that whether your operator is very, very expert or not. So machine will perform all those things. And of course, after 25 years, 30 years, or maybe 50 years also, you can use that particular technology also. So these all are the things basically. Then CAD output is often in the form of electronic files. Yes, of course, you can now save it into the CD, DVD, or maybe your pen drive, hard disk. There are lots of storing devices are available. So where you can put all these CAD models, and whenever you need, just you put it there, or maybe attach with your computer, run that particular software, and you do it. So wherever you stopped in the last time, from that same point you can start for the future also. So no need to start every time from the zero. So basically this is helping to the mankind, or maybe to the manufacturing process. Then CAM, so computer-aided manufacturing. So use of software and computer control machinery to automate a manufacturing process. Use of software to control machine tools and related ones in the manufacturing of workpiece. Now you are preparing it. First you have designed it, and then after that your machine is preparing all those things. So it may also refer to the use of a computer to assist in all operations on a manufacturing plant, including planning, management, transportation, and storage. Suppose now I can give you an example. So basically, if you are having one simple shape over there, and one complex shapes over there. So complex shapes means you need a lot of study. You need to know that which process you have to do it fast and then which one is last. But now when I am talking about any kind of CAM kind of things, so basically you are writing certain models over there. So computer will decide that which one will be fast and which one will be last and how to do all these kind of things. So that means it may also refer to the use of a computer to assist all operations like manufacturing plant, including planning of the management. It's not necessary that every time it is talking about that how to prepare. It will tell you which is the best model over there. And it will give a guide that which one is good, which one is bad. Some key benefits of using the CAM system is faster production process. So basically it will be very, very faster. It will do the machine give the output very quickly. Components and tooling with more precise dimensions and material consistency. So components and tooling. So basically components and tooling with more precise dimensions and material consistency. So basically what is that when you are using certain components and you are using the tooling, suppose you are using a sharp tool over there. So if the sharp tool is touching your workpiece materials, so of course there is certain frictions and rubbing is occurring. So when your machine is constantly rubbing over there, so after a certain time your tool tip get damaged or maybe it may broken, but it is very, very finely broken over there. So what will happen in that particular case? Just a minute. What is happening? Okay, so I'm sorry. So basically what is there? So CAM is basically the components and tooling with more precise dimensions and material consistency. So continuously it is making that same material, same component several times. Uses only the required amount of raw material, of course, because when we are doing for manually, so basically in that particular case what is happening, we don't know that how much material is required, or maybe when we are doing the welding in some portions, basically we are giving, or maybe we are depositing the more materials, but it is not required. So there are so many points where we can wastage our material basically, and then of course that reduces the energy consumption over there. So it automatically control your input parameters. Suppose in some cases you don't need up to that much of heat or maybe that much of temperature, so automatically it will cool it down. Or maybe in some cases it needs some kind of more load, or maybe some kind of more pressure kind of things, so automatically it will comply all these things. So these all are the beauty of this digital manufacturing. Next is CAP, that is the computer-aided process planning. So use of computer technology to aid in the process planning of a part of or product in manufacturing. CAP is the link between CAD and CAM. In that it provides for the planning of the process to be used in producing a design part. Yes, because for any process you need a proper planning over there. So which I was talking about, which you are doing fast. So due to that, automatically it will give the time that if you go by this particular route, so this much time. So that is a very beauty that nowadays you can understand that how your GPS software is basically doing. So when we are using the Google map, so now you can understand it is giving you two to three types of options over there. So if you go by this route, so there is some traffic and maybe some road block is there, it needs 4 hours time. If you go by this route, it is having the faster traffic but simultaneously it is having some tolls. So these all kind of information. So same thing the machine is also giving you. So if you are going by these methods, so it will take this much of time, maybe this much of complexity may occur. So if you go by this, so based on that, you can choose your best options over there. Then factory layout planning. So design assembly lines, equipment and tool requirement in 3D environment, basically. So it will not only tell that which fast, it will also tell that how you are going to put your equipment in which positions, which zone and where, so that everything will be nearer, everything will be very easily reachable, and it will not harm any kind of other operations over there. So continuously everything will be done and it will be finished. Optimize factory space, of course. Maximize capital resource utilization by digitally configuring factory layouts. Yes, of course. So now everything is, we are moving into the digitalization. So basically our signature has become the, now everywhere in that these pandemic situations, when we are putting the signatures also, that is also digitally signed. So now you can think that earlier days, what we are doing, so we have to send the paper, we have to wait it, somebody will sign, then again it will come back to me. So it takes almost 5 to 7 days. But nowadays, within a fraction of a second, basically we are sending it through the mail. So in either PDF or maybe doc format, simply put your signature, you give your consents, and automatically within 5 to 10 minutes, you are getting your approvals. So these all are the things is coming into this. Not only that, if I talk about the digital, so now everywhere we are using the digital. Nowadays the smartwatch has come, so it is also the digitally one. Google eyewear has come, so everything is digitalized. So smartwatch, when you are putting it on your hand, simply it is giving your blood pressure, it is monitoring your health, it is giving your BP, your heartbeat, and sometimes it is giving your heart rate also. So fantastic one. So automatically at the time of running, jogging, or any kind of exercising, so you are continuously monitoring your body systems. So if it is giving any kind of problems or maybe any kind of drawbacks into the results, so it is giving some kind of beep or maybe the alarm, so that you can more cautious and you can consult with your medical practitioners kind of things. So it is fantastic. Next is the ergonomics. Not only that, ergonomics is nothing but the health monitoring basically. So application of physiological and psychological principles to the engineering and design of products, process, and the systems. So basically it will tell about the health of your industry also, or maybe health of your product. So your main aim is not to prepare the product. So you have to prepare the product, you have to use that particular product, you use it for the several times or maybe the several years. So the whole thing will be monitored by this particular process. Next, MRP, manufacturing resource planning, a method for the effective planning of all resources of a manufacturing company, financial and operational planning in units. It has a simulation capability to answer what if questions, extension of closed loop MRP, material requirement planning. It requires a dedication to database accuracy and sufficient computer resources. Yes. So it is giving you, as I told already, so when you are having some dead end, so it will give you some solutions. So dead end means the machine will automatically give you the solutions. So if you go by this way, so you can be able to reach your goal, or maybe you can do it like this. So automatically it will plan properly. It will tell you that exactly that particular process by which you can gain. And not only that, it will save the life of that particular equipment, because sometimes it may happen that suppose some machines needs constant monitoring. So you have to employ certain employer over there at that particular time who will look into that particular machines constantly. Say, suppose I can give you an example. Suppose you are going for any kind of automotive industry or maybe the bearing company. So those they are making that product within a minute. So after certain minutes or maybe certain hours, you have to check it, the products, whether it is proper or not, if you go make it by the manually. But when you are making it digitally, of course, the checkpoint is there, but that checkpoint is also taken care by your equipment itself. So suppose you are making any kind of ball, and now after maybe 5 balls or 10 balls, your ball diameter has been changed. So now it is not possible by the human or maybe any kind of operator that when he is measuring that every ball diameter, and it can be giving you the same results. So now you are having that coordinating system. I'll come into the some subsequent slides. So automatically the machine, every ball constantly it will measure and it will give you the diameter. And now the diameter is within your tolerance limit or maybe the permissible limit. So automatically it will allow it. If it is not, it will retain, and again it will go to the wastage bin, or maybe there is any chance of maybe modifying those things, so it will send that particular ball in that particular zone. So my thinking is that, so basically the human error or maybe the human effort, basically it is reducing. ERP, enterprise resource planning, software and systems used to plan and manage all the core supply chain, manufacturing, services, financial and other processes of an organization. ERP software can be used to automate and simply individual activities across organizations such as procurement, project management. Now you have heard about the ERP also. Even if in our institute also we are using the ERP softwares for purchasing the equipment and all these things. That means what? You are having one softwares, whatever the requirement you are putting over there, you are fixing the date, automatically the tendering is done. Now the company will directly put their tender document to that particular software. Then after that, the software, all the tendering document will come to you. Then you will check whether which one is proper and which one is having some fault. So you will remove those fault, then you will allow those, then automatically the next day your financial thing will automatically open, and then after that you give the order. After giving the order also, it will monitor that whether your supplier is giving your product within the stipulated time or not. If it is failing that particular date, so automatically some kind of extra taxes or maybe extra things will be added to the systems. Then after that, it will constantly monitoring that what is the warranty period. If it is crossed the warranty period, it will give you the informations. So like this way, so one material from first state to the last state, everything is monitored by this kind of digitization. So the software will do, the system will do, and automatically, because when in the industry, how it is possible that one person can deal with n number of parts? How he knows that which parts has already been finished and which I need? So machine can keep all the informations. So now you are having only 1 or 2 numbers of these particular parts. So you have to order that parts. So automatically the machine will give all the informations over there. Next, computer simulation techniques. The simulation-based technologies constitute a focal point of digital manufacturing solutions. They allow for the experimentation and validation of different product, process, and manufacturing system configurations. Simulation comprises an indispensable set of IT tools and methods for the successful implementations of digital manufacturing. Yes, nowadays so many simulation tools has come. MATLAB is there, ANSYS is there. Now you can see ANSYS or maybe the MATLAB. Suppose one materials you are making, you are hitting that particular materials, it is raising the temperature and all these things. Now you can understand, suppose you are having one metal bar and you are giving the temperature around 600 or maybe the 1200 or maybe 2000 degrees centigrade. So after giving the temperature of the 2000 degrees centigrade, how that particular material behave, basically that is also our simulation techniques are giving. So that means you can understand that how good or maybe how effective this one. So in the ANSYS, I am putting all the parameters, I am setting the temperatures, so around 2000 degrees centigrade. So after 2000 degrees centigrade, whatever the load or maybe thermal stress it will be generated, how the metal will, how the temperature will be distributed inside the metal. So everything will be given by that particular software. So now no need to do the experimentally prior to that one. So you put all the input parameters and automatically your machine will do the assumptions. I am not telling that that assumption is 100% truth, or maybe it will properly matching with your experimental one. But there is certain statistics software is also attached. So maybe it can give you 90 to 95% correct results. So that means at least you can get a idea before starting any kind of job, so that automatically your time will be reduced, your wastage will be reduced, your wastage will not be diminished. Yes, that is also the thing, but it can be reduced. Human error can be reduced. So these all are the things. Next is that supply chain management and e-commerce systems. Yes, it's not that you are making any product. After that, you have to sell that particular product. You have to reach to the customer. You have to tell the customer what is the advantage of these particular products. So that also can be doing by the softwares or maybe the digitizations. Advertisement has come, so many advertisement has come. Now you can think another examples I can give you. Suppose in a computer you are using certain kind of Google, and suppose in a Google you are searching, say suppose any books, or maybe you are searching any clothes over there. Now you close it, and after that suppose you are opening any another sites or maybe the other sites, or maybe suppose you are opening your email like Yahoo or maybe Gmail kind of things. You can see that whatever you have searched earlier, like clothes or maybe any kind of books, or maybe today or maybe yesterday or maybe day before yesterday or maybe quite long back, all the advertisement are coming into it. So basically once, sorry, just 2 मिनट में आ रहा है, विमल श्रीवास्तव के पास गया है साइन करने, वहां से सर के पास आ रहा है, ठीक है? आपके ऑफिस में मैं भेज दूंगा सब. वहां से आके मेल हो जाएगा. Okay. Okay. So now the question is that, so basically why I am giving this example. So this example is something like that. That means your machine is recognized what is your choice, what you want, what basically you are searching. So when you are opening some other sites also, so it is showing that particular things, that there are so many matching products has come. So basically it is giving you the advertisement. So what is that? What is that? That is nothing but your machine learning or maybe the intelligence kind of things. So your machine is so intelligent that it has already recognized what is your choice, what is your requirement, and it is giving you that particular advertisement of those products. Even if I can give you another examples also, suppose in the Amazon or maybe anywhere, any Flipkart or maybe Myntra, any online shopping software, suppose you are searching any products, and if you go to the down, you can find that it is showing that similar to these particular products. So similar to these particular products means already these products has been given the attachment with your product, what you are looking for basically. So when you are searching on that, so some similar types of products with different cost, low cost, and not only that, you can make it 3-star, 4-star, 5-star, color, brand, everything you can put it over there. So everything now is the digitization one. So your machine is capable enough to choose your choice over there, and it can give you that, yes, these are products which you are looking for or maybe which you may like, so you can choose from that. Next, what is the key advantage of the digital manufacturing? So basically the digital manufacturing helps manufacturing companies improve productivity in planning and production process in the following ways: enable product, process, plant, resource information to be associated, viewed, and taken through change processes with a consistent and comprehensive approach to production design, allow part manufacturing process to be optimized within a managed environment to produce the flexible work instructions capable of displaying 2D, 3D. I was giving the examples of the 3D printer. Nowadays it has come. 3D metal printer has also come into the market, but it is huge cost. But if you are able to put it into your industry, so automatically you can get the output over there. then along with machining and tooling informations. Reduces compromising cost through simulations by validating robotics and automations. Then, helps in creating factory models faster and ensure they are operating under optimal layout, material flow throughout before production ramp up. Whatever I have told you, whatever I have explained you, now everything has been given point by point. So support Six Sigma. Nowadays, Six Sigma has come, Lean Initiative has come, green, basically nowadays you can heard about one thing, that is the green composites or maybe the green manufacturing process. These all are the things, a graphical environment to analyze dimensional variation. Facilitates the sharing of quality data across your organization by generating complete, verifiable CAD-based machine inspection programs for CMMS and NC machine tools. Executes production process with real-time access to lifecycle data. So this is the basically the whole thing, whole key up that we can do with the digital manufacturing or maybe the advantages. Now manufacturing equipment in DM, digital manufacturing. So I can give you certain examples. First is that numerical control and computer numerical control machine tools. Automotive welding machines, industrial robots, coordinate measuring machines. So I'll show you some examples or maybe the image or maybe some videos, so by which you can understand that how the digital manufacturing is helping nowadays in our industry or maybe in our day-to-day life. So first, when you are talking about the numerical control, that is not the older one. So it has been developed maybe quite long back. So basically the computer, sometimes we are calling it as a computer numerical control or maybe the numerical control. So NC-CNC is the automated control of manufacturing tools such as drills, lathes, mills. So basically you are doing the programming over there, you are putting it into your computer is performing one by one. So it will decide that whether the drill is required fast, lathe, mills and everything, and you will get the final products over there. Sometimes you have to tell the steps also. A CNC machine process a piece of material like metal, plastic, wood, ceramic or composite to meet specifications by following a coded programmed instructions. Yes, earlier days you can see that we are using certain kind of chisel kind of things, or maybe we are using the simple hacksaw. So what the people are using, but nowadays everything is doing by the machines itself without a manual operator directly controlling the machining operations. The program can be written by a person or far more often generated by CAD software or maybe the CAM software. Yes. So the machine should be able to learn your language. For learning that language, you need certain software, because computer only depends upon 0 and 1. It doesn't know anything. So I have to give certain things that which can computer understand. So this kind of software is the interface in between your machines and the human beings. In the case of 3D printers, the part to be printed is sliced before the instruction or the program is generated. Yes, because sliced means you have to give some pause or maybe the break, so that one process will be done and then it will move to the next process and then stop and then it will move to the third process. So like this way the operations is taking place. So now I can show you an examples that how this machines is doing. Basically it is the CNC lathe. Sorry. So now everything has been given into the software. So there is no manually operated kind of things. Okay, so now you have seen that how the machine is basically performing the whole things over there. Same thing like automated welding machines also we are having. So basically it will also help that how to automate the welding process. So it will change the input parameters, it will change the heat, or maybe if you are using some consumable electrode also, so automatically after finishing those electrodes, automatically it will consume the new electrode and it will do the process. Sometimes it may happen that in the process maybe it is not getting the continuous heat or maybe continuous pressure or kind of thing. So automatically the machine will stop. Now this is the thing. So that means you are always having the feedback to your machines that if you are going by this path, if you make any or maybe can get or maybe face any kind of obstacle over there, so feedback will come. Then you start rectify those problems and then you can go for the next one. So many welds that can be handled quite adequately by an automated welding process. Fully automatic welding removes the human element except as an overall observer to make sure the machines are running properly. Yes, that means you are keeping another eye over there to see that whether the all operations are okay or not. That means suppose you can see, suppose you want to weld 5 parts over there and you put 5 operators. So simple, from a table you can observe or maybe you can see that how all the welding is taking place without any operator and all these things. So 6 man's work, basically it has been reduced into the single man work. So, and also if that machine is also facing some problem, it will stop over there. In these setups, the parts and finished work pieces are moved by other machines or conveyor belts, and the welding operation is often continuous over a large number of individual pieces. Provides a high quality weld since they are totally uniform in their application of the electric arc or other welding tool. Next, industrial robots. So generally we see into the movies or maybe somewhere else, but nowadays this kind of robots has come into the market. Now you see, you cannot find any kind of operator over there. So whatever the things, already you can see there is one computer monitor that is also taken care by the robots itself. So that is the interesting thing. So now you are giving only the instructions to that particular robot, and robot is giving the instruction to all other robots, and the thing is done. So maybe in future we'll not be so surprised that one car is only making and you are sitting in your home and the total company is running by this kind of robots and your car is dispatching. So from flat sheet to just to the final products. Maybe near future we can see all these kind of things. Who knows? So basically the application of robots in manufacturing can be divided into 3 categories. First is the material handling, like material transfer, machine loading, unloading, processing operations like welding, painting, palletizing, assembly and inspections like assembly, disassembly, product inspections and testing, packaging and labeling. Next, CMM, which I was talking about, that is the coordinate measuring machines. I have given you only single examples. There are n number of examples by which you can check your parts. You can check that all the height, all the surface properties, textures, or maybe its width or dimensions. You can measure its surface roughness, kind of things. So everything can be measured. If you are making any kind of hole over there, whether the diameter is uniform or not. So a coordinate measuring machine is a device that measures the geometry of physical objects by sensing discrete points on the surface of the object with a probe. Various types of probes are used in CMMS, including mechanical, optical, laser, and white light. Depending on the machine, the probe position may be manually controlled by an operator or it may be computer controlled. So that means, sorry, that means what? So basically everything you are controlling by sitting into the computer. I can give you another one examples. Suppose you are traveling and you are going to the airport. You are keeping your bags onto the scanner. So the scanner belt is continuously moving. Only a single person is sitting over there. Now, the only one single person is sitting over there, and just what it is doing. So he is seeing that what is there inside your bags and all these things. If it is having any dangerous item or maybe any explosives, simple, they are putting it down and then they are asking for the explanations and all these things. So that means it is a simple kind of checking. Now, it is planning that it is maybe it may be bring to the, that system is bring to the India or maybe sorry, in Delhi and some other airports also, but I found it in USA and Germany that the same systems they are having. But now the question is that after when your baggage is coming out from your scanner, it is having two paths basically. One path is blocked, so your bag is don't have any kind of explosives or maybe materials, or it is okay, then it will follow the A path. And if your bag is having certain problems, so automatically it will gate will open, it will follow the B paths. So now you can understand, so A path is continuously giving you the bags which doesn't have any problem, and B path, so when automatically, then the B path, the bag will automatically come and it will be kept in a particular place. The person will come and they will check it. And not only that, if you I have seen it into the airport USA also. So suppose when you are coming through that particular gate, so basically in India, basically we have to stand over there, we have to put our hands and the person will come, he is having the scanner over there and it will thoroughly scan your body. But in outside in USA, if you go and you can stand over there, so simple, two doors are there. Through that particular doors, you have to stand over there. There is no human intervention. Automatically the scanner will come and it will just rotate throughout your body and it will tell you that whether you are having everything okay or wrong. If wrong, then only the human intervention will come. So now everything has been digitized. Everything has been, now the manual intervention has been reduced, and our planning is to reduce this manual intervention as less as we can. But of course, that is having some pros and cons also, that which I am going to talk in the tomorrow's lecture, basically. Next, basic introductions of the artificial intelligence. Now come to the artificial intelligence. Till now we are talking about the digital manufacturing. So artificial intelligence as an academic discipline was found in 1956. Now you can understand it is not so new. The goal then as now was to get computers to perform tasks regarded as the uniquely human things that required the intelligence. That means till now the computer was working depending upon your input parameters. If you say go, the go. If you say no, that means no. But now when I am talking about the artificial intelligence, that means the computer is having the brains. It can take its own decisions. So if this path will fail, automatically I'll take this path and I'll achieve the goal. So it will like basically the mimicry or maybe the cloning of the human brains. Computers emulate the human thought process. AI means getting a computer to mimic human behavior in some way. The computer is doing something intelligent, so it's exhibiting intelligence that is artificial. Yes, of course, that is the artificial things. So the earlier use of AI was in image recognition. Yes, or maybe you can understand nowadays Google. Suppose if you use certain kind of Google products, say suppose iPad or maybe the Google MacBook, so there is having some Face ID. So unless if you click on the Face ID, so it will at the first instance it will click your face image over there, and it will be digitally saved over there. So every time if you open it, so just it will take your image face image, it will match and that will open. If it will be handled by some other persons, it will never open. So that means the image recognition kind of things is already taken place. Extracting the meaning from text, yes, of course. Suppose you are writing any coding or anything, so it can extract the essence, or maybe it can extract the coding. So we are just getting the final products, but what is the steps are involved for making that final products also? So that also steps it can be extracted. So what is machine learning? So difference between humans and computers. So human learn from past experience, at least they try. Computers or machines need to be told what to do. So that is the difference in between the human and computer. Computers are strict logic machines with zero common sense. Yes, of course, it doesn't have common sense. Whatever, maybe how good you have trained this particular computer, it will work like that. That means if we want them to do something, we have to provide them with detailed step-by-step instructions on exactly what to do. We write scripts and programs for computers to following these instructions. So how the computer will behave. The process of learning begins with observations or data, such as example, direct experience, instruction. Yes, because everywhere first we are reading the books earlier days. So nowadays books is also digitalized. Now the thing is that suppose you are searching, or maybe you are searching one particular things. Say suppose in the mechanical point of view, suppose you want to search something about the machine design. So you will go some good writer books which basically we read at our BTech times or maybe the MTech time. But nowadays, no need to go for any kind of things. Simply you write that particular topic and Google you give you n number of informations from different literature, paper, books, magazines about that one. So now you can understand that how quick everything has come into the things. Then instructions in order to look for patterns in data, make better decisions in the future based on the examples that we provide. Machine learning concept consists of getting computers to learn from experience past data. That means somebody has already done it. He or she has shared his or her experience into the computer. So Google just keeping all those things. So when I am searching about the same topic, so it is giving all the experience, all the papers, all the data, everything. Machine learning, as defined by Arthur Lee Samuel in 1959, the basic definitions of the machine learning is a field of study concerned with giving computers the ability to learn without being explicitly programmed. That means earlier days we used to give the program from start to end up to the full stop. But nowadays, maybe we are not giving certain particular program, or maybe we are not giving exactly the things. Let computer decide and take the final call. So that also can be possible. Machine learning makes computers more intelligent without explicitly teaching them how to behave. Machine learning has revolutionized countless industries. It is the underlying technology for many apps in our smartphones, from virtual assistants like Siri. Siri is a very good one in Apple. So those who are using the Apple, they are very well acquainted with the Siri. So whatever you can tell to the Siri, Siri can do. Best example another I am giving you, Alexa. So Alexa, if you tell the Alexa switch off the light, so automatically the light will be switched off. If you tell the Alexa, please play this song, so it will automatically done. If you ask the Alexa, what is the today's weather, it will give you the example. Certainly, it will give you the informations within a fraction of a second. So these all are the things to predicting traffic patterns with Google Maps, which I was talking about. So machine learning is one way to achieving the artificial intelligence. Now, machine learning methods, supervised machine learning algorithms. It can apply what has been learned in the past to new data using level example to predict future events. Starting from the analysis of a known training data set, the learning algorithm produces an inferred function to make predictions about the output values, as I told already. So it will give you the predictions. If you follow this path, what can happen? If you not follow this path, what can happen? So like this way, you can choose the right path, right operations, right manufacturing process, and right thing, so that wastage will be less, time will be less, and your cost will be less. So everything will be less, and your productivity will increase. Unsupervised machine learning algorithms are used when the information used to train is neither classified nor labeled. Unsupervised learning studies how systems can infer a function to describe a hidden structure from unlabeled data. Then semi-supervised machine learning algorithms fall somewhere in between supervised and unsupervised. So both label and as well as the unlabeled data. It typically uses small amount of labeled data and large amount of unlabeled data. So it is a mixture kind of things. Then reinforcement, that means you are putting the third party over there. So reinforcement machine learning algorithm is a learning method that interacts with its environment by producing actions and discovers errors or rewards. Trial and error search and delayed reward are the most relevant characteristics of reinforcement learning. Allows machines and software agents to automatically determine the ideal behavior with the specific context in order to maximize its performance. So some common applications of AI is that basically personalized coupons or product suggestions we received after shopping online. AI-based self-packing or self-driving cars, Tesla car. So if you know about the Tesla car, so automatically it is taking its own decisions wherever the traffic, where to stop, what should be the speed in the traffic. Virtual assignments like Siri, Alexa, social media news feed, chatbots, trading and investment, traffic management, etc. Now, what is basically the role of artificial intelligence in general? So artificial intelligence in modern terms generally refer to computer systems that mimic human cognitive functions. It encompasses independent learning and problem solving. Most contemporary artificial intelligence projects are currently better understood as types machine learning algorithms. So simple, this thing, just you see from the below. Decision making, it is directly go to the brain itself. Increased accuracy, it's going to the brain. Then from brain, what is coming? Solve complex problems, perform the high level computations. So all mixing together, and then it is taking the final call over there. AI-driven system can discover patterns and trends, discover inefficiencies, predict future outcomes based on the historical trends, which ultimately enables informed decision making. Best example in the trade market also, or maybe the share market. It can interpret that what should be the shares or maybe the cost for future, maybe after 10 days, after 15 days, after 20 days. That means it is taking all the data, it is there is certain softwares or maybe the programs is already there, it is manipulating all the data, and then after that it is giving you the predictions for the future. AI-driven systems are potentially beneficial for many industries, notably heavy industry. While the application of artificial intelligence in heavy industry is still in its early stages, applications are likely to include optimization of asset management, operational performance, as well as identifying the efficiencies and decreasing the downtime. Now come to the use of AI in manufacturing. The use of AI in machine visions. What is machine visions basically? Machine visions is the technology and methods used to provide imaging-based automatic inspection and analysis in industry. As I told already, it extracts information from an image on an automated basis. The information extracted can be a simple data, good part, bad part, signal. As I told already, whether it's width is proper or not, or matching within the tolerance limit or out of that. Complex set of data. Role of AI in machine vision. Artificial intelligence-based startups are being developed machine vision tools that detect microscopic defects in products at resolutions well beyond the human visions, means which we cannot see by our naked eyes. Basically, that can be seen by the computers or maybe the machines. So how much we can save for future, because when you are putting any faulty parts, maybe in future some kind of problems may occur. So by seeing through this computer or maybe machine, you are diminishing those particular errors or maybe the loss. The machine vision tools use a machine learning algorithm tested on small volumes of sample images. The computer not only sees the errors but processes the information and learns from what it observes basically. Then animations in manufacturing with the use of AI. In 2014, China, Japan, United States, Republic of Korea, Germany together contributed to 70% of the total sales volume of robots. So everything is automated. In the automotive industry, a sector with a particularly high degree of automations, Japan had the highest density of industrial robots in the world at 1414 per 10,000 employees. Now you can understand. Employees are there, still they are using the robots just to minimize the human intervention and the error kind of things. Industries have began delivering the vision of integrating software and artificial intelligence into every phase of the manufacturing cycle. Generative design approach in manufacturing. Designers or engineers specify design goals as well as material parameters, manufacturing methods, and cost constraints. I have explained into details. I'm not going into the details once more. Into the generative design software. The software explores all potential permutations for a feasible solution and generates the design alternatives. The software also uses machine learning to test and learn how each iteration means one way, two way, how many cycles basically. So it is taking the final call. It is not going for a single one. So there are so many iterations. So after that only it will give you the final result to test which iterations work and which iterations fails. AI and ML in robotics. Artificial intelligence is set to disrupt practically every industry imaginable, and industrial robots in no different. The powerful combination of robotics and AI or machine learning is opening the door to entirely new automation probabilities. These all are things basically we are seeing in so many videos and in movies also. Currently, artificial intelligence and machine learning are being applied in limited ways and enhancing the capabilities of industrial robotic systems. We have yet to reach the full potential. We have not totally changed into the robotic systems. So now we are into the phase in between. So 50% of the human intervention and 50% with the robot and all these things. But current applications are promising. Now, tenets of artificial intelligence and machine learning in robotics. There are 4 areas of robotics process that AI and machine learning are impacting to make current application more efficient, where vision, grasping, motion control, and the data. So these 4 zones basically the AI and machine learning is boosting more, and the robotic process is coming. What is vision? AI is helping robots detect items they have never seen before and recognize objects with a far greater detail. Yes, of course. In some foreign countries, if you go for the simple immigration process, so nowadays you no need to show the passport or any kind of things. Simple, there is one machines, no persons, nothing, only cameras there. You have to put your eyes over there, so they will scan your retina, and if they will match with the data, and automatically your door will open. And if there is certain problems over there with your data and anything, so gate will never open. So these kind of things. So vision. Then grasping. Robots are also grasping items they have never seen before with AI and machine learning. Simple, just you go and use your camera in your mobile phone. So you can see when you are taking any new picture, there is nothing is coming. Suppose one picture, already one person's, suppose your kids or maybe your wives or maybe your spouse picture you have already taken, and the same person's picture again if you want to take it, so you can see one square line or box are coming. So that box is basically, it is telling that that person's picture is already taken by this computer, so that, or maybe sorry, that mobile. So that means that mobile can recognize that this image has already been taken before. So machine learning helping them determine the best positions, orientation to grasp an object. Machine learning helps robots with dynamic interactions and obstacle avoidance to maintain productivity. Data, AI and machine learning both help robots understand physical and logistical data patterns to be proactive and act accordingly. Then types of industrial robot application. Supply chain and logistic applications are seeing some of the first implementation of AI and machine learning in robotics. Example, a robotic arm is responsible for handling frozen cases of food that are covered in the frost that normal human don't put their hands over there. So the frost caused the shape of the objects to change. The robot is not just presented different parts occasionally, it is being continuously presented with differently shaped parts. AI helps the robot detect and grasp these objects despite the variations in shapes. Example 2, picking and placing a large volume, which is not possible by the human, of different part types in a warehouse. These volume of part types would not be profitable to automate without machine learning. But now engineers can regularly feed robots images of new parts, and the robot can then successfully grasp these part types. So they are taking those images and they are keeping it inside. And then when the new thing is coming, first they are matching. If matching is successful, they can perform the same task. If matching is not successful, then again you have to feed that particular data. Like this way, you have to increase the database of that particular equipment. AI and machine learning will have a transformative impact on industrial robots. While these technologies are still in their infancy, they will continue to push. Yes, of course, they are very in the infant stage. So it needs time to mature. And of course, in near future, it will come. What is the advantage of integrated AI and ML with digital manufacturing? AI-driven machines ensure an easier manufacturing process along with many other benefits at each new stage of advancement. Technology creates new potential for task automation while increasing the intelligence of human and machine interaction. Some benefits of AI include directed 24/7 productions. Even if you call any call centers, so now it is all 24, automatically your machine is giving the answer. Whatever you are having the query, the machine is solving those problems. No need to put the operator at 24/7. So automatically you can understand that whatever the service, that it is more wide open, it is getting more easier. So everything is now very closer to us. Safer operational environments and reduced operating cost. Direct automation, AI and robots can execute actions repeatedly without any error. So continuous, it can perform. They can design more component production models by building automation solutions. They are also capable of delivering superior levels of assurance on their own. 24/7 production. So as I told already, so continuously the machine is working. Safer operational, of course, few human laborers are performing, so it is not too dangerous. Chances of accidents has been reduced. Human interaction has been reduced. Losses of error has been reduced. So these all are the benefits. Operating cost, of course, overall operating cost will reduce when you are reducing wastage, you are reducing the energy input, you are reducing the manpower involvement. So these environmental impacts, yes, of course, it is safer, it is making certain kind of greens, fossil fuel consumption, our greenhouse gas emissions has been reduced. So now the computer is doing, the robot is doing. So these all are the things. Additional benefits, AI and industrial automation have advanced considerably over the years. There has been an evolution of many new techniques and innovations such as advances in sensors, increase of computing capabilities. It also helps to make quick data-driven decisions, advance process effectiveness, minimize operational cost, facilitate product development, and enable extensive scalability. Of course, certain disadvantages too. It is high cost at the one time. Though the cost has been decreased in the past few years, individual development expenditures are still very high for basic AI. Yes, of course. Small business with a low capital investment may have difficulty. For larger companies, the price of AI may be higher depending on how much AI is involved in the process. Yes, when you are increasing the percentage of the AI involvement, so automatically the cost will increase. Because of higher cost, the feasibility of leveraging AI becomes a challenge for many companies. Nevertheless, the cost of utilizing AI can be cheaper for companies with the advent of open source artificial intelligence software. Reduced employment opportunities, yes, of course, because you are reducing the manpower, so automatically job might be lost because AI would replace them. Any job that involves repetitive tasks is at risk of being replaced. AI decision making, yes, there may be chance of the programming error. So that is the coding error or programming error, or maybe sometimes in between of any operations your computer has maybe stopped or maybe crashed or something kind of thing. So these can occur. So these all are the drawbacks of this AI. Environmental impact, electronic waste is expected. Yes, of course, you are using increasing number of computers, so automatically the UPS, mouse, keyboards, your machines, your robots, your plastic products is increasing. So that is creating some kind of environmental impacts at the time of wastage, or maybe after using it. They are all time, every time they are not recyclable. AI trained to act on environmental variables might have erroneous algorithms which can lead to potentially negative effects on the environment. Yes, of course. It is not only that we are totally dependent on the human, on the machines. Now I can tell you one examples also. There are now very few number of people, if I ask their own mobile number, they will able to tell, because they never dial their own number in their own mobile. So probably they have forgotten. So now, and also earlier days when you were having the normal phone in our house, maybe we can remember at least 15 to 20 numbers of relatives and the neighbors. Now, if I ask you, tell the 5 mobile numbers of others, probably you can't say, even if I am also. So basically the thing is that now everything is machine oriented. We are totally depending upon this kind of softwares and digitization. So automatically our memory loss is also taking place. Then when machines develop learning and decision making ability that is not coded by a programmer, the mistakes can be hard to trace and see. As such, the management and scrutiny of AI based process are still essential. So for this, it's a thank you very much for your kind patience and giving me this opportunity. So I am closing my lecture for today's session now.
Great, sir. Very good, very interesting session.
So it's okay, fine from my side.
Professor Kaushik, very interesting session.
Okay, thank you very much.
Really means you have so comprehensively given told about digital manufacturing and then the applications of machine learning and this thing. Really means I liked it and learned a lot from this. Thank you so much for beautifully explaining this.
Thank you, sir. Thank you.
Sorry, little bit network issue was there. Am I audible to all of you?
Yes, sir. Yes, sir.
Yes, sir, you are audible, sir.
Little bit network problem is here. For that reason, I disconnected for a moment. Given a Kaushik Pal sir given a very nice presentation and shown the clear-cut roadmap of the application of AI and ML in our computer-aided design and manufacturing line. So I have seen that all of you are enjoying, sir. And my humble request here that all of you please attend the program very seriously, because all of our maximum are we are faculty and some are from industry peoples. I really thanks to all that you participated very nicely, and continuously I'm observing that more participants are here with me, us in this program. And feedback link, regarding the feedback link, sir, I will share with you through your Gmail, through your mail account shortly, because I have some technical issues here. So regarding that feedback, don't worry, bother about for the moment. You will. My request is that as per the scheduled time, you all of you please join in the program. Make this FDP with a grand success, because various speakers from the reputed institute, they are from their busy schedule, they are given the time for us, and let we will share our their experience, and we will gain some experience, and we will want and we will really practically implement it for the day-to-day life, and we also guide our or train our student to fit for the industry. So thank you so much, and I request to all of you please join in afternoon sessions.
Okay, sir. Thank you, sir. Thank you, sir. Have a nice day.
Thank you.
Sir, time, sir. Afternoon
Thank you,
session
sir.
time.
Time 4 o'clock, sir. Sir, very nicely all of you. You're cooperating me a lot. Okay, sir. We will enjoy the day, because very difficultly we with our request to the speakers, they agreed. And each and every speakers are you can say that very much experienced persons in this application field. Thank you.
Sir, will the link be the same?
Link will be the same, sir. Through the link will be same, and time I will put it from as per your schedule time. You can directly join those 10-15 minutes before, and because participants are more, so they will not face the problem. So for every moment we are planning to send the YouTube link. If that is not opening, if you have any difficulty, then directly you can contact with me. No problem at all. I am here to help.
Sir, I have a question, sir.
4 o'clock,
Hello?
right?
Hello, sir,
Yes,
I
sir.
have a question.
Sir.
Sir, actually, we haven't received any feedback link so far, sir.
Yes, I have not shared with you. I will share with you through the mail.
And sir, during the session, we have some confusions and see we have some queries, sir. Whom to contact
Yes.
to discuss those
Sir,
queries?
no problem. Sir, no problem. The same sir will come tomorrow. Okay, and if necessary, you can send to me.
And
I will.
sir, we are requesting from our side. Can you please open the call for feedback, sir? And we can we have some questions related to the topic which sir was discussed. So
Okay,
can
okay,
you
no
please
problem.
open the session for questionnaire also from the customers like panel end?
Yes, sir. Yes, sir. Tomorrow on afternoon onwards, you will get all feasibility there. No problem at all. And the same
Actually,
professor will come.
during
Same
session,
professor will come
doubt
tomorrow
clearing
morning.
session. So if the doubt kind of sessions are also there, then we are more happy.
Sure, sir. No problem at all.
Okay, thank you so much, sir.
Yeah. Thank you, sir.
Sir, will you share the PPTs, sir?
Sir, I will discuss. I will try to share with you.
Yeah,
Thank you, sir.
because
Thank you
of that,
for
there is a
help.
doubt clearing session on every session, sir. Then we are more happy. Then the panel
Sure,
also can ask the questions.
Sure, sir.
Yeah, thank you, sir. Thank you so much.
Thank you, sir.
you.